The next topic under Module 2 is infiltration indices. We have already studied infiltration and the methods to find out the infiltration rate. So infiltration is defined as the downward movement of water from soil surfaces into soil mass through the pores of soil. And we know that the infiltration term was first used by Horton in 1935 in order to describe the phenomena of soaking water into the soil, giving the difference between infiltration and percolation. So when rain happens, it falls on the ground surface, and the initial raindrops or the amount will be absorbed by the soil layers. Then it goes down, which is called infiltration. So if the water, if it is a heavy rainfall, and if the water again going to the deep layers of soil, then it is called percolation. So the entry of water in the soil through the soil surface is infiltration, and if the process of absorbing water or the downward movement of water is still continuing, then the process is called percolation. These 2 points are very important. That is, when a rain happens, the infiltration process happens first and then it continues as percolation. So when this percolation stops, the infiltration, it is obvious that infiltration have already stopped earlier, but if the infiltration stops, the percolation can continue, because the water is flowing through in a downward movement through the soil layers, and when infiltration stops, the percolation, the downward movement is still continuing because the water is flowing downwards. Okay, but when the percolation stops, we have to understand that the infiltration has already stopped. That is why there is no water for percolation. So these points are important. Now we studied infiltration capacity in the first module. There is a maximum rate at which the soil can absorb water is the infiltration capacity. And you can see the infiltration capacity curve here. So it indicates the infiltration is high at the beginning of a storm when the soil is completely dry, and then what happens, it decreases as the soil becomes saturated, and it ultimately reaches a constant value. If you already know this infiltration capacity curve, the values of it, then you can directly find out the infiltration at a particular or a given time. But this kind of calculation is not always possible in hydrological computation for computing surface runoff and also the flood discharge, because it is not that convenient. So it is more convenient to use the infiltration indices or the average constant values of infiltration rates. So these values are going to be always convenient and accurate. So let me explain what are infiltration indices. So these are the average constant rate of infiltration. Infiltration indices are two types. They are Phi Index and W Index. So you can calculate the infiltration rates for computing surface runoff and flood discharge. These are the most suitable methods. Now let's see one by one. First, Phi Index. Phi Index is the average rate of rainfall above which the rainfall volume is equal to the surface runoff volume. So to understand this, you can look at this graph. So this is a hyetograph drawn between time and rainfall intensity. Time is marked in x-axis and rainfall intensity is marked in y-axis. So this diagram clearly shows at 1 hour the maximum rainfall is this much, that is more than 10 mm per hour. So at 1 hour this is the total rainfall, and at 2 hours this will be the total rainfall. Okay, and this is for 3rd hour, 4th hour until 7th hour. This is going to be your total rainfall. Okay, now you can see some shaded portion here, which is nothing but the runoff. Okay, so this is your total rainfall, and the shaded portion will be your runoff, this portion. Okay, so this is your runoff. So what will be the remaining portion? If you subtract the total, the runoff from the total precipitation which happened in 1 year, what will be the remaining, this value? It is going to be your loss, which is nothing but infiltration loss. Okay, so I'll give you a better image. This is your total rainfall at 4 to 5 hours. Then this is your runoff. And if you subtract this runoff from the total rainfall, you will get this portion, which is going to be your loss. Okay, which is nothing. In Phi Index, we always take the losses as just infiltration loss. Okay, we have so many types of losses like evaporation loss, interception loss, depression storage, which is the water which is stuck in pits or cracks. So that can also be taken as a loss, which is depression storage. So this is going to be your infiltration loss. So Phi index is P minus R by TE. So the the runoff value is subtracted from the total rainfall. That is what I said now, by the total time of the rainfall or the storm. Okay. So I'll explain once again. So in order to determine this Phi index, you can see a horizontal line drawn, which is a dotted line. So this horizontal line is drawn on the hydrograph such that the shaded portion, the shaded area above that line is equal to the volume of surface runoff. And what about the unshaded portion below this dotted line? The unshaded area below this horizontal line actually represents all the losses, which includes evaporation, interception, depression storage, or infiltration loss. But it is assumed that all these losses are due to infiltration only. We are not taking any other losses other than infiltration. So we are considering all the losses as just infiltration loss. Now moving on to the application of Phi index, we have mainly three applications. Phi index can be used to determine the surface runoff, then it can be used to predict the infiltration, and also unit in order to develop a unit hydrograph, which is going to be our next topic under module 2. Then W index. As we already said, Phi index is the average rate of rainfall, but W index is the average rate of infiltration. So there is a difference between Phi index and W index. One is the rate of infiltration, and the Phi index is the average rate of rainfall. So this can be found out by the formula P minus R minus S by T. So P and R are same as Phi index. P is the total rainfall, R is the runoff, and S is going to be the total loss. So the one difference between Phi index and W index is, in Phi index we are calculating, or we are taking only the infiltration loss as the total loss, but in W index S is the total loss, which includes evaporation, infiltration, depression storage, etc. So all the losses are considered in this W index. And also it is said that the W index value is more accurate than the Phi index because as I said, the interception, depression loss, which are considered as a part of infiltration. Thus W index is always in other ways it is less than Phi index, because in W index from P minus R, we are also subtracting all the losses, but in Phi index, the losses are not subtracted. All the losses are not subtracted. So W index is always a less value compared to the Phi index. So it is difficult to estimate the interception and depression losses. So W index is not commonly used in practice. Phi index is already is often used. So this is just an explanation on infiltration indices.